Hello everybody. So today we're going to do more on section 4.1, and we're going to talk about the substitution technique versus the addition elimination technique. So we're going to start off and we're going to suppose we have two functions. One f of x is 4x minus 1, and the other one is g of x is equal to negative 2x plus 5. And it says where, and what that really means is which x value does f of x equal g of x. In other words, it's called the point of equilibrium. It's where these two lines visually cross. Well, the first way is through substitution to be able to figure this out. And what you're actually doing is you're taking the idea that f of x is equal to g of x at some point. And so remember, f of x is really just the y, and g of x is just the y. So somewhere the y's are equal. So we're going to use that assumption, and we're going to substitute in this expression for f of x, and this expression for g of x. And so you end up with 4x minus 1 is equal to negative 2x plus 5. And we're going to use the addition property of equality, and we're going to add 2x and add 2x, and we got 6x minus 1 is equal to 5. We'll add 1, and we get these to eliminate, and so we have 6x is equal to 6. Then we divide each side by 6, and we get x equals 1. Well, that's all nice and tidy because it's y equals and y equals effectively. So what if the functions are not explicit? In other words, they're not solved for y. What if you have them in the form where it reads 2x plus y is equal to 7 and 3x plus 4y is equal to 2? Well, there's sort of a process that we follow, and the process goes like this. So pick a variable that is easy, and I put this little arrow, say, point over to here, so you follow that arrow over there. This is easy. This one's easy to solve for because the coefficient is 1. Okay? If all the numbers are even, then find one that goes into all the other ones easily. Okay? Anyways, what we're going to do is we're going to solve for that variable. Here we go. We have 2x plus y is equal to 7. We're going to subtract 2x. We're going to subtract 2x and get y is equal to negative 2x plus 7. We cannot combine these because they're not like terms. Now, this is a little weird, but this is something that I had to kind of figure out for myself when I was figuring this out when I was younger. I visually needed to create a space in the other equation, in this equation, for the stuff that's equal to the same variable to go in place of. So in other words, this y and this y are equal at that moment. And what I did was I had to create a space for this expression to fit. That y equals that y. And so this expression can replace that y, and it replaces it here, hence the term substitution. And remember, technically what's going on is f of x is equal to g of x. The two y's are equal at that moment. And so we plug it in here. Okay, now I gotta turn pages. And we're back up here. Yes, notice the apple and the apple. All right, and so this part here is going in place of, and recall this is really our y. Well, when f of x is equal to g of x, we also have another property that the x's are going to be the same as well. And so when we're working this through, we're first going to fill in the space. We're going to have 3x plus 4 times the quantity negative 2x plus 7. That's the negative 2x plus 7. It's filling in that gap. Then we're going to go ahead and distribute. So we're going to end up with 3x plus 4 times the quantity negative 2x plus 4 times 7 is equal to 2. Now, this becomes negative 8x. This becomes 28. We can combine like terms, and the reason we can combine like terms, the reason we know those x's are the same thing is when the y's are the same, the x's are the same. We're going to subtract 28, and we get a negative 5x. These come together to give you the negative 5x, and that's a negative 26. Divide by negative 5, divide by negative 5. A negative divided by a negative is a positive, and then you get x is 26 over 5. Now, it doesn't really matter which one you plug in, but you plug into either equation in one of its previous forms when it has both variables, and you can find out what y is. Well, I just took this answer and plugged it back into x there. And so I have negative 2 times 26 over 5 plus 7. Well, I did some scratch work right here. Negative 2 times 26 over 5 is the same thing as negative 2 over 1 times 26 over 5. And we multiply straight across and we get negative 52 over 5. So this becomes negative 52 over 5. We need to get a common denominator. So 7 over 1 becomes 35 over 5 because we multiply top and bottom by 5. Now the denominators match and we get negative 17 over 5. And that is our ordered pair, or our solution, or our point of equilibrium. Now we're going to do the same problem using the addition elimination technique. And the trick is to first of all start off with lining up your x's, your y's, your planes, and your equals. So there are times when they aren't lined up and you need to line them up, so you have to manipulate your equations a bit. Now, the second thing is we're gonna work with the x's. We're gonna try and get the x's to match and then eliminate. And the way we do that is we ask ourselves, well, what do the coefficients, and in this case, the 2 and the 3, both go into? Well, they both go into 6. 2 times 3 is 6. So what I'm gonna do is I have to keep in mind that I'm gonna need to eliminate them. One of them has to drop off, or the x's need to drop off. And so we don't just multiply by 2 and 3. We multiply one of them by a negative if they aren't already negative. You want one to be a negative 6 and one to be a positive 6. So back up here. We're multiplying this whole equation by 3 and this whole equation by negative 2. When you do that, you get 6x, 3y, and 21, and then negative 6x, negative 8y, and negative 4. And notice these signs are opposites. And when you add them, they get eliminated. And here you get your negative 5y, and here you get your 17 over negative 5. I'm sorry, 17. And then you divide by negative 5, and you get your negative 17 over 5. And then you just repeat that substitution process, plug it back into either of the original equations. I went with the easier of the two because it doesn't have a coefficient. And then I worked my way back to the same answer. And I'll just hold there for a second. So I use the addition property of equality to eliminate that number on that side, and now it's over on this side. It does go across the equal sign as its opposite. Get a common denominator. We've done that work previously. We end up with 52 over 5, and we have 2x equals 52 over 5. I'm going to multiply by a half, and multiply by a half. It's the same as dividing by 2, but when you're working with fractions, it's easier to multiply by a fraction rather than dividing by the whole number. And then you end up with 26 over 5, which is the same answer that we had. Now, there are 3 things that lines can do. They can cross, which is what we just had, but you can end up getting something like 0 equals 0 or x equals x. And what that means is the 2 lines are the same. And no matter where you are, all the values work. So your answer is actually all real numbers. If you get something like 4 equals 7, then there's no solution. They never cross. So I just did a real quick here. I did 2 examples. So if we have these 2 equations, we're going to multiply the top one by negative 2. And what happens is you end up with a 0 equals 0. You get negative 6x plus 6x, negative 4y plus 4y, negative 16 and 16. You got 0 equals 0. That's an all real numbers situation. Those 2 lines are just multiples of each other. It is possible as well that one of the lines doesn't match up perfectly. You still get all of this the same on the left-hand side. When you add, you get 0 equals negative 6. And the procedure I followed was the same. I'm running out of time, so I'm talking a lot quicker now. All right, I have to stop the video. I hope that makes sense. And by the way, this is the empty set, right? There's no solution. All right, I got to post this one.